Good day, everyone. Welcome to today's presentation of Hamilton's method by Group 1. We will delve into the introduction, description, definitions of terms, steps or procedures, sample problems, solutions, interpretations or answers, conclusion or generalization, and references. By the end of this lesson, you are expected to understand what Hamilton's method is and its significance in various fields, grasp the fundamental concepts and applications of Hamilton's method, comprehend how to solve problems using Hamilton's method and obtain solutions. Lastly, learn the systematic steps or procedures. Before we delve into our discussion, let me ask you something. When was Hamilton's method created? Well, Hamilton's method created after the first census in 1790. The U.S. government needed a way to fairly represent the voices and opinions of its citizens. In 1792, Alexander Hamilton proposed the Hamilton method of apportionment that accounted for the population sizes of each state and the number of voting seats available for the House of Representatives. Introduction. In 1792, Alexander Hamilton proposed the Hamilton method of apportionment. This method calculated each state's lower and standard population quotas. By comparing these quotas, the remaining seats could be distributed and occupied. Description. Alexander Hamilton proposed the method that now bears his name. His method was approved by Congress in 1791, but was voted by President Washington. It was later adopted in 1852 and used through 1911. He begins by determining to several decimal places how many things each group should get. Since he was interested in the question of congressional representation, he used the language of states and representatives. So he determines how many representatives each state should get.
Alexander Hamilton's method is a mathematical approach used for apportioning seats or resources among different groups based on their sizes. Here are some key terms related to this method. First is quota. The ideal number of seats a group should receive based on its proportion of the total population. Second is lower quota. The greatest integer less than or equal to the group's quota. Third is upper quota. The smallest integer greater than or equal to the group's quota. Fourth is Hamilton's method. It is a process where each group initially receives its lower quota. Any remaining seats are then distributed one by one to groups based on the highest fractional part of their quotas until all seats are allocated. Fifth is fractional part. The decimal component of a group's quota after the lower quota has been subtracted. Sixth is apportionment. It is the process of assigning seats or resources to various groups based on their sizes.
I am here to talk about the steps or procedures in Hamilton's apportionment. Step 1. Calculate the standard divisor. Divide the total population by the total number of seats available. Determine how many people each seat should represent. Do this by dividing the total population of all the states by the total number of seats. Step 2. Calculate the standard quota for each group. Divide each group's population by the standard divisor. Divide each state's population by the divisor to determine how many seats it should have. Record this answer to several decimal places. Step 3. Allocate the lower quotas. Assign the whole number portion of each group's standard quota as the initial number of seats. Cut off all the decimal parts of all the quotas, but don't forget what the decimals were. Add up the remaining whole numbers. This answer will always be less than or equal to the number of seats. Step 4. Distribute surplus seats. Identify the groups with the largest decimal portions of their standard quotas and assign the remaining seats to them one at a time until all seats are allocated. Assuming that the total from step 3 was less than the total number of seats, assign the remaining representatives, one each, to the state whose decimal parts of quota were largest, until the desired total is reached.
Let's learn on how to solve the apportionment problem using Hamilton's method. Consider a country with 5 states and 51 seats in Congress and population distribution. First, we need to find the standard divisor. Let's take the sum of the population from all the states, which is the total population is 1,430,877, which to divide into the total of seats in the Congress, which is 51, so 1,430,877 divided by 30 is 28,056. And to find the quotas, we need to take each state's population and divide it by the standard divisor, which is 28,056.41,176. The states have a 983,988 population. To get the quota, we need to divide into the standard divisor. 983,988 divided by 28,056.41,176, which is the standard divisor, and we're using 4 decimal places, which is the state A will be approximately 35.0718. State B is 7.4451. State C is 5.8456, and State D is 2.6347, and State E we have 0.0029, and the total of each quotas is 51 seats. Now let's move for initial part in Congress. Let's move the decimal parts of the quotas, which is State A will receive 35, State B receive 7, State C receive 5, State D receive 2, and State E receive 0. Then we have a total of 49 seats. Now we're assigned to remaining seat to the state whose quota has the largest decimal part. We notice that the state C and D has the largest decimal part. Therefore, state C and D will receive one more seat, means for the final apportionment, state C will receive 6 and the state D will receive 3. So the total of the final apportionment is 51 seats. Notice here that the total is 51. We've used all the seats in Congress.
Based on the idea of proportionate representation, Hamilton's technique is an effective instrument for guaranteeing fair representation. After figuring out how many people each representative should represent using a standard divisor, it determines the quotas for each group according to their population. These quotas, fractional portions, are important because they dictate how the remaining representatives are distributed following the first assignment that was made using whole numbers. Priority is given to the groups with the largest fractional parts. This approach ensures that representation is proportionate to population in an organized and mathematically sound manner, which makes it useful for a variety of purposes, including allocating funds for public services or assigning seats in legislative body. Hamilton's strategy has drawbacks while being widely seen as a fair and successful. One such drawback is the Alabama's paradox, which states that raising the total number of representatives may result in a group losing a representation. Furthermore, the computations required can be complicated, particularly when there are a lot of groups or representatives. All things considered, Hamilton's approach offers a useful foundation for guaranteeing justice and equity in representation and resource distribution, but it's critical to be conscious of its limits.